Using subqueries. In this nugget, we're going to broaden and deepen our mastery of the SQL select statement by learning how to embed one query inside of another one. That is the nutshell definition of the subquery. We're going to go farther than just a simple definition. We're going to understand the types of subqueries, single row and multi-row, standard and correlated, and we'll learn how to write SQL to answer more complex questions using these subquery types. Without any further ado, let's get started. Of course, the $10 question for this nugget is, what are subqueries exactly? We could define them, as I mentioned in the opening whiteboard of this nugget, as nested queries. As of Oracle Database 11g R2, you can actually have up to 255 levels of nesting with one statement inside of another. That is to say, one query inside of another. Now, of course, we want to subscribe to the keep it simple rule wherever possible, naturally. Subqueries are useful when we know what value we're looking for using a select statement, but we don't know the exact value. Thus far, we've used select, and then we've specified columns from one or more tables with or without joins, and as you know, we've used the where clause as our workhorse to do row-level filtering. Well, we're going to find in this nugget that where you don't have a really definite idea of your where values, your conditions, this is a great spot to actually embed a second select statement and even a second where clause to come back with a result that's then fed into the parent where. That brings up the next point. When we use subqueries, they work from the inside out. We have the outer query, which is the first select statement that Oracle sees, and then your nested query, your subquery that's enclosed in parentheses, is called the inner query. And because we need the result of the inner query to perform the outer query, that should tell us logically of the execution order. So there you have it. Please remember that. Subqueries can be used really widely in the select clause, the where clause, the order by, from, even when we get into more PL/SQL territory like case. You can embed queries inside other queries all day long. However, you'll notice the asterisk here. For our exam objectives, we're going to be working with subqueries exclusively that are attached to the parent or outer query where clause. The reason for this is, number one, we haven't yet come to DML, where we're actually changing data in tables. As it happens, a common use of subqueries is to populate rows when you're using create table or insert, etc. But because we haven't yet gotten there, we're dealing just with selects. We're going to run subqueries to customize our where clause. Speaking of use cases, a core principle of adult education, as you know, is why am I learning this? Why is this important? What I have on this whiteboard in really small print, you can find this information in the Oracle 11g documentation, but because Oracle put it so succinctly and completely, I decided to reprint it here on this whiteboard. Where we can use subqueries for many different purposes, we're concentrating on this bullet point here that says to provide values for conditions in a where clause or a having clause. That's exactly what we're doing for our exam objectives. But you'll notice that we also have a lot of DML and even DDL capability with subqueries. You'll notice in this first bullet point that we can use subqueries to define the sets of rows to be inserted into a target table using the insert or create table statements. Really nice way to move or copy data from one table to another. We're actually going to revisit that idea a little bit later in the course. Can do the same exact thing when we create views. Now, we haven't yet talked about what a view is, and it's beyond the scope of this nugget to do so, but yet again, we'll have to revisit subqueries later in this course when we cover views. When we're changing values of tables, we can make bulk edits to those existing rows using subqueries with the update statement, and then finally, to define a table to be operated on by a containing query, where we place the subquery in the from clause. Bottom line, friends, is that subqueries are awfully versatile. They're somewhat of a Swiss Army knife that allows you to take your original select statement and really broaden it and deepen it depending upon your needs. As it happens, Oracle Database supports two types of subqueries. The first of those two types is called the single row subquery. In the next whiteboard, we'll look at the second variety called the multi-row subquery. You'll remember when we discussed functions earlier in the course, I taught you that that functions that return a single value are called scalar functions. Well, that same vocabulary word comes back to haunt us now in our discussion of subqueries. We can look at single row subqueries as scalar subqueries because these subqueries return a single column and one row's worth of data. So bottom line is your embedded select statement is going to come back with one and only one value to be passed into the outer select statement. Now the hallmark of the scalar or single row subquery is that we can use these comparison operators that we've used before when I originally taught you how to use the where clause. We have equality represented by the equal sign. We have not equal to represented to the less than greater than combination, less than greater than, less than or equal to, or greater than or equal to. And then an example, this is our first real life example of a subquery. We're selecting product and price from the prod table where the price equals. Remember, there's that issue of ambiguity. When you know exactly what you're looking for, in this case, we want the price to be the product that has the highest price in the table. If you know that, we can just specify where price equals $9.99 or $19.99, whatever that value is. When you have a question where you're not exactly sure what that value is, that's a good reminder to you, hey, why don't I try to leverage a subquery here? Another mental bookmark, so to speak, that might lead you to use a subquery with your SQL is if you find that you're executing separate atomic select statements as precursors to a final destination one. So in other words, you could run the select max price from prod, get an answer, and then compose the outer query as select product price from prod where price equals, and then plug in whatever value you got. You can combine those two queries into a single statement as you're seeing here for efficiency. Now, besides the use of comparison operators, another giveaway that we're using a scalar subquery is if we're using one of our friends, the aggregate functions that we learned about earlier in the course, min, max, average, and so forth. So in this simple example, we're invoking the max function and passing in the price column to determine the price value that's highest in the prod table. And once that inner query is resolved by Oracle, that scalar result is passed into the outer query where price equals, and then of course the user receives his or her result. As an example of using a comparison operator in our subquery, we could just reformulate this as select price from prod where some arbitrary column equals some other value or greater than, less than, etc. Now, the possible problem that you can run into here when you're using comparison operators in your scalar subquery is that Oracle will in fact raise an error if more than one row satisfies that condition. That is to say, let's say we reformulated this subquery as select price from prod where category equals 10. Now, if one and only one row from the prod table satisfied that, then the subquery would return that scalar value to the outer where clause, and the query would be processed normally. However, if more than one row came back from that inner query, Oracle would raise an ORA 1427 error that says single row subquery returns more than one row. And that's your indication that you'll need to reformulate that subquery. In other words, you'll need to use one of the keywords supported by the multi-row subquery. Speaking of which, let's now turn our attention to that second type of subquery. In the event that our subquery is likely to return multiple records, you're not going to lose anything by shifting your subquery syntax to that of the multi-row subqueries. Now, the common misconception is that no operators are allowed when you use multi-row. That's not exactly true. You can use operators, but they have to be used with conjunction, or in conjunction, I should say, with one or more of the following logical comparison terms: in, all, not in, some, or any. Now, each one of these is going to specify your condition. Now, let's have a look at an example here. Let's formulate a query using our employees table in the HR schema to look at all employees whose salary is higher than those in Department 80. That is the question that we want to answer here. So we can select first name and last name from employees where salary is greater than. See, so we are using comparison operators in conjunction with one or more of these logical keywords. Now, in this case, Let me put brackets around it. Our outer query goes from the outer select to the comparison operator. Our inner query involves our keyword and then our inner query. The all operator will return true. These are all Boolean type operators if every value in the list satisfies the condition. So in this case, we're specifying all select salary from employees where department ID equals 80. Now, if we just did salary greater than and then our inner select to try to formulate it like a single row function, then we'll get that ORA error that I mentioned earlier. We have to specify using one of these Boolean operators what's going on. So in this case, we have to strictly evaluate every value in that list satisfies that condition. So any employees in this table whose department ID is 80 will be rounded up, and those values will be passed into the outer where, and we only want to see employees whose salary is greater than that of those department 80 employees. That makes sense? You may find, and you'll see this in the upcoming demo, that in is perhaps the most frequently used operator for multi-row subqueries. In compares a list of values for equality. Any checks whether any value in the list makes the condition true. It's kind of similar to the OR operator that we used earlier in the course. Not in is simply a negation of in. You can use not to negate any of these just like we could before. Some is actually identical to any. They can be used interchangeably, and we looked at all just now. To wrap up the theory part of this nugget before we jump into our demo, it's crucial that you understand what correlated subqueries are. This refers more in terms of how Oracle processes the query as opposed to anything you're doing syntactically. Now, it's certainly possible and probable that you're going to use subqueries at times that refer to more than one table. So you can actually construct subqueries that perform many of the same functions as joins do. Now, what is different between a simple subquery that we've been using thus far and a correlated subquery is, as I said, how Oracle processes the query. A correlated subquery involves interdependence between table and column references in the outer query and that of the inner query. Specifically, let's look here. The inner query uses data from the outer query, and the query will execute once for every row in the outer query. Stated a slightly different way, for every row processed by the inner query, the outer query is processed as well. You'll remember with a simple query, we fully resolve the inner query completely independently of the outer query. We get our inner query results and then pass those results to the outer query. The correlation here in this term means that we're processing both inner and outer row by row. As an example, let's take a look at the query that's on this whiteboard that comes from a really nifty site called onekeydata.com. In this query, we have two tables. One, store information, aliased as A1, that appears in the outer query, and geography, aliased as A2, that appears on the inner query. So in our outer query, we first want the sum of sales where the store name in store information is equal to. Now, when we're dealing with multi-row subqueries, in denotes equality, but we can't use equal, remember, just our syntax rules apply, so we'll substitute in, and then in our inner query, we're selecting store name from geography, a related table, where the store names match. In other words, wherever the same store name exists in both tables, those rows will come back, and then the sum of sales for those rows will be computed. The correlation here is in the where clause because the test for equality on the inner query references an outer table. So row by row, we're going to have to correlate the outer and inner queries. Let's look at one more example. This comes from Wikipedia, and this is kind of tough to wrap your mind around, so I think a second example is germane. Now, the example in the Wikipedia article for correlated subquery uses generic ANSI syntax, so we're going to have to modify it slightly. The question that we're looking for an answer to is that we want a list of employees having more salary than the average salary of all employees in that employee's department. So you see you have a couple variables moving simultaneously here. And we have our outer query, select employee number and name from employee, and we're aliasing that table to make it explicit. We need to think of name resolution here. And salary is greater than, this concludes the outer query. Now this doesn't have the in keyword. For Oracle, we'll need to include in and then our inner query that selects the average of salary salary from employee where department equals E1.department. Now, because the inner query is dependent upon the outer query reference, we're going to have to recompute the inner query for every employee. And it actually tells us that explicitly down here. In the above nested query, the inner query has to be executed for every employee as the department will change for every row and the average salary will also change, you see? And then it tells us the effect of correlated subqueries can also be obtained by using outer joins. Different methods, different tools for different purposes. Now let's jump out into our demo. In this demonstration, we'll work with subqueries. As you see, we're logged into Oracle SQL Developer as the HR user, and as usual, all of our examples come from tables contained within the HR schema. Now, the first question that we're going to answer with subqueries is, show me all of the employees from the employees table whose salary is greater than that of an employee named Russell. So we're picking on an employee named Russell. We want to first of all know what his salary is, and then we want all employees whose salary is greater than his. Now, this is a perfect example for the use of subqueries. How would you know, just asking that question, what Russell's salary is? I suppose you could call him or her up. I'm not sure how politically correct that would be, though. You would probably craft a query similar to what you're seeing on line 4. Select employee ID, first name, last name, and salary from employees, where last name equals Russell. And in running that query, we see that employee ID 145, aka John Russell, has a salary of $14,000. We can then write a second query that's pretty much like the first. It's just that our where evaluation will be where salary is greater than $14,000. And it looks like there are 3 employees whose salary is greater than that of Russell. Now, given that we did not know initially what Russell's salary is, just that we wanted to know, show me employees whose salary is greater than Russell's, we can work with subqueries. That's what we see here on line 13, where we're grabbing those same 3 columns, employee ID, first name, and last name, where salary is greater than. There's our outer query. And our inner select, our inner query, contained within parentheses. Remember, we want to be as explicit as possible in our SQL. We're running select salary from employees where the last name equals Russell. So we're containing one query within another, and then I'm throwing in the order by clause that will take those results. That is to say, the inner query results get passed to the outer query runs, and then and only then do we do our ordering. We want to see those results back in ascending order by employee ID. And if I run the query, you'll notice that the results are exactly the same as the previous one I showed you. It's just that here we can do everything in one fell swoop, so to speak. Now, you have to think about what you're evaluating, and what do I mean by that? Well, on line 15, our outer query is looking at the salary column from the employees table. So our inner query has to come back with that column name, otherwise the expression just isn't going to make any sense. You might be thinking, well, Tim, that's kind of intuitively obvious. I just wanted to make it double underscore so as we go along. Let's have a look at another simple single row subquery. On line 19, here we want to see all employees from the employees table whose job ID is the same as that job ID of employee ID 121. So remember, the subquery answers the question. We don't know what employee ID 121's job ID is, so we're going to write this as a subquery to answer that question. And as it turns out, these 5 employees have the same job ID as employee ID 121, which is STMan, whatever that means. Now, if I make just one change to the inner query, taking the equality operator and making it, in this case, less than, you'll notice we see that ORA 1427 error. Single row subquery returns more than one row. That's because, as you can expect, we have employee IDs, that is to say more than one employee ID that's below or less than 121. So we would need to rewrite this using multi-row subquery syntax. Now, I mentioned at the beginning of this nugget that you can nest up to 255 levels with these subqueries, in addition to nesting within, that is to say outer, inner, inner, and then inner, 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 etc. You can also run subqueries in parallel. You'll remember that we have the Boolean operators and you'll see on line 26 we have a fairly complex query that does have a compound where expression, with each one of those having an associated subquery. Remember, the inner queries are parsed first. So in this case, we have on line 29, select job ID from employees where the employee ID is 188. So Oracle is going to look up employee ID 188 and return the job ID to line 28. So you'll have your result passed there. Because on line 30 we have another outer query parameter and we have another inner query to resolve, select salary from employees where employee ID is 180. That comes back with a scalar value that's passed and substituted into line 30. So this again is just to underscore how the subquery works. Subquery processed first, then outer query. So this and means rows are going to be returned from the employee table only where the job ID is such and so, and the salary is the same as employee ID 180. Fairly complex question, but it'll give us an answer all day long. Line 33 gives us an example that's very close to one that we saw earlier in the whiteboard portion of this nugget, where we want to see the salary for all employees who is equal to the max of salary from employees. And we see there's just one, Stephen King. And if I just select this bit here, let me temporarily add a separate semicolon so I can select and run just this little batch, we see that the max salary from employees is indeed $24,000. Let's rerun that, and there you have it. Now we could reformulate this query where the salary is greater than the average of the salary from employees. And of course we can figure out what the average is just by running a separate select, just for grins. The average is 64.62. Speaking of average salary, to locate the jobs with the highest average salary from the employees table, this example brings in some review from previous nuggets. We're selecting two columns. You'll remember when we're doing grouping, we have a target column and an aggregate function. So we want to return job ID and average salary, grouping by the job ID column. And then you'll remember also, by way of review, when we're doing grouping, we don't use where, but we use having to do row level filtering. In this case, having average salary equal to, and then because we don't know what that value is, we're going to select maximum average salary from employees and group by job ID. This is indeed a fairly complex query. And the scalar result from this is that, of course, President, it would make sense, has the highest average salary at $24,000. Finally, to turn our attention to multi-row subqueries, in this example on line 48, we're selecting employee ID, first name, last name, salary, and department ID, where the salary falls within, or equality, equal to 7,000, 8,300, or 8,600. And sure enough, we come back with 5 rows with individuals whose salary matches one of those 3 values. We can look at everyone else by negating in, run that query. We see everybody's whose salary is not in there. Now, to take the basic mechanics here of the multi-row expression and apply it to subqueries proper, let's whip up a quick example of that. In this very simple example, the inner query here selects employee ID from employees table where the first name starts with S. The outer query selects employee ID first name last name from employees where the employee ID in or is equal to. And there you have it. Again, we can negate to get everyone whose last name is not beginning with S, and so forth. Using subqueries review. I wonder if your brain feels a little bit more stretchy than it was before you started this nugget. This is definitely some mind-expanding content. At this point, you should be able to intelligently define what subqueries are and how and why they're used. We also understand now the types of subqueries, namely the single row or scalar and the multiple row varieties. We understand query processing, which is either simple or correlated, and we understand and can apply SQL syntax to write both of those subquery types. Again, this was some pretty difficult content, and we'll be revisiting it as we proceed throughout the course, just like we've been revisiting and building upon all of our SQL skills sequentially. I hope that this has been informative for you, and I'd like to thank you for viewing.